Okay, so let's go over the basics of geothermal. Uh, Mostly this video is designed for people that are in the early stages of getting a geothermal system installed, and for people that really want to understand sort of the fundamentals of how the systems work. The biggest thing that I've found with geothermals is, unfortunately, there's a lot of contractors out there that claim to be experts. Most of these guys have a pretty good HVAC sort of experience and history, so they do understand quite a bit about how furnaces are designed, and many of them come from installing gas furnaces, oil furnaces, heat pumps. And unfortunately, the regulations that surround the geothermal industry are not really overly governed, so it's pretty easy to have someone claim to be a geothermal expert and start giving advice and trying to sell systems. Now, with all of that said, there are a lot of really good and talented individuals that are out there installing them. My company has been doing geothermal for probably about 6-7 years now, and in the area that we are, we've probably installed somewhere in the neighborhood of about 150 units. So during the course of those installations, there's been a learning curve for myself and for some of my guys. And so I thought what I'd do is share some of the tips and perhaps give you people out there an indication of what to look out for, some of the pitfalls that you could run into. So let's start with, in my opinion, the most important thing with any geothermal system, and that's the actual loop design. And I say that because it doesn't matter how good the equipment is that you've purchased. It can have the highest COP rating, it can be classed as one of the best heat pumps out there, but the truth is, if it's not installed correctly or the ground loop is not done properly, it doesn't matter how good the system is, it's just not going to function at the peak efficiency that you would expect. So with ground loops, the easiest way for me to explain things in layman's terms is you have to understand that there's only a certain amount of energy in every cubic foot of earth. So first thing you want to do is you want to excavate. You want to make sure that you've excavated down an honest 5 feet. Generally when I do them, I try to use 6 foot as my bench. And sometimes, depending on the topography, you may come across something where you'll lose, 6 inches here and there. So generally, if you aim for a 6 foot trench, most of the time you'll be able to achieve that. And anywhere that you're not able to achieve it, if you've only lost, 6, maybe 8 inches, you're still under that 5 feet. And for this area where we live, frost line generally, it'll go about 3 feet down. Now that's just a rule of thumb, depending on the type of winter that we've had. It has been known to come down a little more. So on a sort of worst case scenario, you could probably see a frost line in the 4 feet range. But that doesn't take into consideration where the ground loop is. And what I mean by that is, for example, if that ground loop perhaps goes underneath a driveway or is underneath anywhere that there's going to be traffic, that traffic will push that frost level down 5, 6, maybe even 7 feet, depending on the type of volume that you're going to get with the traffic and the type of weight, the type of vehicles that are going to cross. So with that, it's really important that the first thing that you do is when you situate the ground loop, you avoid any type of area where there will be a high traffic load. To be honest, even something as simple as foot traffic, as a rule, I try to avoid that. So you want to aim to place the ground loop in an area where it's basically undisturbed soil. The next piece of advice that I'll give you with the ground loop is getting back to that knowledge of, there's only so much energy in a cubic foot of soil. It's extremely important that you do not undersize that ground loop. You do not try and take any shortcuts when you're excavating. A lot of times guys will try and put a little bit more pipe into a trench than you should. It will save the contractor a lot of money in excavating charges, but the problem to the homeowner is then that ground loop is not going to be installed properly, and you're going to have the ground loop pipes too close together. And as soon as you exceed the maximum energy that you can get out of that cubic foot of ground, then you're going to drop your efficiency levels. So generally, there's all different types of loop designs. The most common is where you'll run out your pipe 300 feet, you'll turn it and you'll bring it back. Now, when you're doing a single circuit in a trench, ideally I like to use a minimum of 36 inches of clearance. So I'll put the one pipe on one side of the trench and the other pipe on the other side of the trench. 36 inches is a pretty good rule of thumb. If you can excavate a little bit bigger, whereby you would have enough property to do that, absolutely I would recommend to go bigger than that. Usually, as far as if you have an unlimited size of ground that you can put the loop in, generally you want to have your excavator spend the additional money on excavation. And really how you do it is you just increase the size of the bucket. So on a smaller excavator, a 36-inch bucket is pretty standard. Go up to a 48-inch bucket. You can even go out to a 60-inch bucket. Some of the ground loops that we've done where we had no problems with the amount of area, we would always use a 60-inch bucket. It adds a fair bit of cost to the excavation, but when the project is done, once you take the tests on the ground loop, you'll see that your COP, your coefficient of performance, is much greater than if you try and cheat on your ground loop. The other big thing to take into consideration with ground loops is the type of soil. So really the gold standard for soil would be a very wet, clay-like type soil that has the highest level of conductivity. Worst case scenario would be something like a very gravelly or a very dry sand. That would be sort of your lowest level of conductivity. If you do have those type of soil conditions, and we have ran across that where we've excavated and we've literally just gotten down to nothing more than like a gravel base, the only way that you can work around that is once the excavation is done, you'll need to put at least 6 inches of soil. So we'll truck in soil, ideally clay or a very wet loam type soil, and we'll put that in as a base. The big plus of doing that is it helps protect the pipe, because people don't realize that these pipes will expand and contract, and if you're on an actual gravel, it's literally like laying your pipe on sandpaper. So over a period of time you'll get erosion on the pipe and you could have a problem. Again, the biggest concern is conductivity. If it's on that nice base that you lay down, your coefficient of performance will be substantially increased. Then we would lay the pipe, and then we would again lay another 6 to 8 inches of soil over top before we do any of the backfilling and putting the gravel back into the ground loop. These are the type of things that are not very common, and these are the type of shortcuts that a lot of contractors unfortunately will take when they excavate. the truth is, you know, they've given the homeowner a price, and anything above and beyond just a standard excavation will cut into their profit margin. So obviously they want to reduce their costs as possible. So I would definitely encourage a homeowner to take the time to talk to the contractor, and before they excavate, have an agreement in place that if you as the homeowner don't know what the soil conditions are, if during excavation it's determined that the soil conditions are very poor, then you would want a contingency built into your agreement whereby additional soil would be brought in. Probably the next biggest thing that I've seen a lot of the rookies do when they're doing excavation is, again, a cost-cutting measure, is they'll try and cheat the length of the trench. Now, the big disadvantage to doing that is obviously at the end of the trench there's not enough room to put the pipe. So what some guys will do is kind of just coil it around a little bit at the top and then start to bring it back. Now, if out of all of the worst things you can do, that's probably the best case scenario that I've seen guys do. The absolute worst thing that I've seen them do is run it all the way down to the end of the trench, not have enough room, so they'll make the turn, they'll come back, and when they get to the beginning of the trench, instead of having the ends of the pipe being equal, they have all the surplus pipe. And I've seen guys actually just literally cut the pipe down. They'll take off, you know, 15-20 feet, and most commonly it's only 20 feet of pipe, it's not going to make a difference. It actually makes a huge difference, not only from the fact that you're losing the potential BTU pickup of that pipe, but more importantly, what you do end up losing is you get different pressure drops. So what will happen is, depending on where that circuit falls in the loop design, potentially you could have a pressure drop at that point. So what will happen is the bulk of the energy is being picked up in, say, circuits. If you're doing a 6-circuit loop, a 6-ton loop, so you would pick up the bulk of the energy in circuits, say 1 through 4. Because of the pressure drop, you're not getting that liquid going through the last even 2 loops of pipe. So again, now you're losing the entire energy that you would have gained. For sure, the system will still function, but where you're really going to notice it is when you put the gauges on to test your COP. The numbers are just going to fall short every single time. Now, the method that I just described, that is based on sort of what I would call the older style of doing the header pipe. And in that system, you're basically sending 2 header pipes out, and you're reducing the size of the nozzles all the way down. What we have came across, and it's pretty common since the last, say, 2 years or so, is it's called a solar header pipe, and it's basically it eliminates pressure drops, and instead of having the pipes go all the way out, it basically just looks like the fingers on a hand. You'll have it's a plastic pipe, and it'll have the circuits coming off, so you'll have 6 circuits that come off, and then on your return they'll hook up to the reverse side of that. The big advantage of that type of application is if somebody did make a mistake and they cut a pipe wrong, or they shortchanged the loop design, the pressure drops are not quite as noticeable in that type of configuration. So what I'm going to do is I'll continue this video with more discussions and more tips. What I'm going to ask from the viewers is that in order for me to gauge whether or not these videos are helpful, please either subscribe to the channel or at least like the video, and then that way I can gauge how much interest is in this topic, and I'll continue to put more and more updates out there. Thanks a lot.